Hello. Today we are working to find out if the line containing points C, E, F, and J have a constant proportionality. Let's look at a few triangles to investigate and see if that's true. By using point I, we can create a lot of different triangles. Create a triangle with ABC that has 3 going horizontally and 2 going vertically. We can create a lot of triangles in between with decimals, like 4.79 going horizontally, 3.19 going vertically. We go AED that has 6 going horizontally and 4 going vertically. And so let's view a few triangles just to investigate to see what happens. So it says find the ratio of the vertical leg length to horizontal leg length for triangle ABC. To view triangle ABC, click on the box to place a check. So I'm going to place a check and notice that a red line for ABC shows up. 2 and 3. So the vertical leg is 2, the horizontal leg is 3. So to make a ratio of it, we write the ratio of vertical to horizontal is 2:3. Or if I had a fraction, it'll be 2/3. That's my ratio for triangle ABC. Okay, so now I'm going to uncheck triangle box ABC, and it says find the ratio of vertical leg length to horizontal leg length for triangle ADE. So now we're working with ADE. So what I'm going to do is I'm going to check the box says ADE so that I can see. Let me drag I out the way. See my numbers. So looking at my numbers, my vertical leg length is 4. My horizontal leg length is 6. So when I make a ratio of my vertical leg length to my horizontal, I have 4:6. Now, simplifying a ratio is similar to simplifying or reducing a fraction. You find a number that can go into both numbers. So what number can go into 4 and 6? Well, they're both even numbers. So 2 can go into 4 and 6. So when you divide 2 into 4 and 2 into 6, the ratio will reduce to 2:3. So 4:6 simplified is 2:3. Coinky dink? I think not. Okay, so now let's uncheck triangle ADE. So it says find the ratio of vertical leg length to horizontal leg length for triangle AFG. To view triangle AFG, click the box to place a check. So I'm placing a check. I'm going across the bottom. The horizontal leg is 7.5. My vertical is 5. So again, in order to make my ratio, does that make it better? In order to make my ratio, it'll be 5:7.5. And believe it or not, if I reduce 5 over 7.5, it will reduce to 2:3. So you can do this a few different ways. Now some people, they will change the decimal or clear the decimal from the fraction first. So that will make it 50/75 or 50:75. And then 25 goes into 50 and 75, and that reduces to 2:3 or 2/3. Alright, so similar triangles, angles are congruent and the ratio of their corresponding sides are in proportion. They're proportional. So I got to look to see, are the triangles similar? How do we know? So looking at the three triangles we made triangle ABC, triangles ADE, and triangles AFG. Of course, remember, we can make plenty more with that I, but those are the ones we're looking at for now. So in order to see if they are similar, I have to see if my ratios are proportionate. So you can reduce them to see if they create the same thing, which they did because we reduced them already. Or you could create a fraction equaling another fraction and cross multiplying to see if it works. Okay, so look in here. 2 times 6 is 12. 3 times 4 is 12. So those two triangles are proportionate. And then 6 times 5 is 30. 4 times 7.5 is 30. So that make those two proportionate. So that means I do have triangles that are similar. If I want to check ABC with AGF, then I'd have to go 2 times 7.5 and 3 times 5. And both of those would equal 15. They equal the same thing. So because they equal the same ratio, same number, when I cross multiply, they're similar. Or as I said, we could just reduce them as we did. Both ways work. Okay, so it asks, does the line containing points C, E, F, and J have a constant proportionality? So does it have a constant proportion, a constant ratio that we get every time? So when we had triangle ABC, it was 2/3. Do you remember how much it was when we did triangle ADE? It was 4/6, yeah, but what did that reduce to? It reduced to 2/3, right? And then when I look at triangle AFG, my ratio is 5:7.5, but that also reduced to 2/3. So what is my constant proportionality? It is 2/3. And how do you know? Because we worked it over and over again. All right, now I have to use the ratio of the legs of the triangles to determine the constant of proportionality, which is similar to what we just did. So we have 2/3 as my first ratio, 4/6, 5:7.5. And again, if I reduce 4/6 and 5:7.5, I would still get 2/3. So notice a lot of times in math, we use different words to mean the same thing. So it says the steepness of a line is called the slope of the line, and is the ratio of vertical change to the horizontal change for any 2 points along the line. We also talked about, in class, we talked about slope being rise over run. Either one of those would work. So I need to figure out what is my vertical change, what is my horizontal change. So if I do each one of those, I already have my ratio of my vertical to horizontal. So what is the slope of line AJ? It will be 2/3. How does it compare to the constant of proportionality? It is the same. So guess what? Any triangles that are created with the same slope will be similar if they have the same angles, equal angles, and have the same constant proportionality. So when we're talking about constant proportionality and slope, we're talking about or discussing the same thing. So if a question asks, what's the slope of the line? Then that's a similar question, and they would want the same answer to, what is the constant proportionality? Or what is the ratio for our similar triangles? Thank you for your time. Have a great day.